I am Dr. M.K. Murali, Assistant Professor of Physics, J.J. College of Arts and Science, Pudukottai. Now we are going to discuss about semiconductor laser. Semiconductor laser, it is a two-level laser. It is obey the characteristics of light. The power output is 1 millivolt. Nature of output is pulse or continuous beam. Introduction of the semiconductor laser. Semiconductor diode was demonstrated in 1962 by two US group led by Robert N. Hall at the General Electric Research Center and by Marshall Northern at the IBM D.J. Watson Research Center. The semiconductor laser is made in mass quantities from vapors of gallium arsenide or similar crystal. Principle of semiconductor laser. When the PN junction is forward bias, that is, the P end of the diode is connected to the positive terminal of the battery and the N end of the terminal is connected to the negative terminal of the battery. The holes and electron diffuse through the junction and combine with each other. Meanwhile, light radiation or photons are emitted. This is called a recombination radiation. Classification of semiconductor laser. The semiconductor laser classified into homojunction diode laser, heterojunction diode laser. Here, homojunction means only one junction. Heterojunction means number of junction. The case 5 junction. The heterojunction diode laser further classified into double heterojunction diode laser, single heterojunction diode laser. Homojunction semiconductor laser. The systematic diagram of homojunction semiconductor laser is as shown in figure. Homojunction diode laser are those in which P end and N end of the diode are made of the same semiconductor material. That is, P layer and N layer made up of same semiconductor material. Example, gallium arsenide laser. They use direct band gap semiconductor material. The PN junction acts as an active medium. The crystal is cut at a thickness of 0.5 millimeter. Applied voltage is given through a metal contact on both surfaces of the diode. A pulse beam of laser of 8400 Armstrong is produced. Working of homojunction semiconductor laser. The systematic diagram of homojunction semiconductor laser is as shown in figure. The P end of the diode is connected to the positive terminal of the battery. N end is connected to the negative terminal of the battery. The holes and electron diffuse across the junction and recombine with each other. And the recombination to produce radiation in the form of light. Energy level diagram of homojunction. The homojunction semiconductor laser is a two-level laser. The region around the junction contain large amount of electron in the conduction bond and a large amount of holes in the balancing bond. The holes and electron recombine with each other and this recombination produces radiation in the form of light. That is, the stimulation emission occurs for the conduction bond and for the balancing bond. Heterojunction semiconductor laser. Heterojunction semiconductor laser are those in which P end is made up of one type of semiconductor material and the N end is made up of another type of semiconductor material. Example, gallium, aluminum, arsenide, diode laser. Here, use direct band gap semiconductor. Heterojunction semiconductor laser consists of 5 layers, namely gallium arsenide p-type, that is upper layer, gallium aluminum arsenide p-type, gallium arsenide p-type, that is in the third layer is acts for the active medium. The fourth layer is gallium aluminum arsenide for n-type, gallium arsenide is for the n-type. The end space of the third layer is highly polished and perfectly parallel to each other to reflect the laser beam. One end is partially polished to release a continuous beam. There is a working of the heterojunction semiconductor laser. The systematic diagram of the heterojunction semiconductor laser is shown in figure. The P end of the diode is connected to the positive terminal of the battery, N end is connected to the negative terminal of the battery. That is for the upper layer. N end means that is for the lower end. That is for the fifth layers. The holes and electron diffuse across the junction and recombine with each other. The recombination produces radiation in the form of light. Energy level diagram of heterojunction. The region around the junction contains large amount of electrons in the conduction bond, large amount of holes in the balancing bond. The holes and the electrons are recombined with each other and the recombination produce radiation in the form of light. Characteristics of semiconductor laser. Most semiconductor laser operated in 0.8 to 0.9 micrometer or 1 to 1.7 micrometer spectral region. Wavelength of emission determined by band gap. Different semiconductor material used for different spectral regions. 0.8 to 0.9 micrometer based on the gallium arsenide, 1 to 1.7 micrometer based on the indium phosphide. Pumping method is direct conversion. High power laser usually 1 millivolt. Comparison. The comparison between homojunction semiconductor laser and heterojunction semiconductor laser. The homojunction semiconductor laser P and N region are made up of same diode material. Here P and N region are made up of different diode material. Active medium is single crystal of PN diode. Active medium is third layer of P type of material among the 5 layers. Pulse beam, here it is a continuous beam. Wavelength is 8300 Armstrong to 8500 Armstrong. Wavelength is 8400 Armstrong. Example, gallium arsenide, indium phosphide. Example, gallium arsenide, gallium aluminum arsenide, indium phosphate, indium aluminum phosphide. Advantages. They are lightweighted and portable. Battery supported, easily releasable. Capability of direct modulation of into gigahertz region. Small size and low cost. Capability of monolithic integration with the electronic circuitry. Compatibility with the optical fibers. Disadvantage, due to relatively low power production, these lasers not suited to typical laser application. The temperature affect greatly the output of laser. Beam divergence is much greater as compared to all other laser. Cooling system required in some cases. Application: fiber optic communication, barcode reader, laser pointer, disk reader, laser printer and scanning, directional lighting source.